Okay, we are going to be looking at 2010 VCAA exam 2, section 2, question 1. Part of the graph of the function g with a domain of -4 to infinity is graphed with all real numbers, and g of x is equal to 2 log base e x plus 4 plus 1 is shown on the axis below. Find the rule and domain of the inverse of g. Okay, so the first thing we need to be thinking about is the domain. We know that the range of G is going to give us our domain of our inverse. So the range we can see is all real numbers, so that straight away tells me that the domain of the inverse is just going to be all real numbers. Next thing, when we're talking about the inverse, all we need to do is switch the x and y around. So that means when instead of having y at the start, I'll have x. X is equal to 2 log base e y plus 4 plus 1. I'm going to do this in a couple of steps to simplify it. So to get y by itself now, I'm just going to take away 1 and then divide by 2. So that will give me x take away 1 over 2 is equal to log base e y plus 4. The next step is to get y by itself. I'll use the understanding of the relationship with exponents. So that will give me a base of e to the power of x minus 1 over 2 is equal to y plus 4. I want y by itself, so I take away 4, and that will give me e to the power of x minus 1 over 2, take away 4. So next it's wanting us to, on the set of axes above, sketch the graph of the inverse. Label the axes intercepts with the exact values. So before I get started with that, we know when we got a -4, there's an asymptote. So that means when I've got -4, I will do a dotted line. Apologies, it's not straight because I'm doing it on a computer. And I'll label it as y is equal to -4. The next thing, we need to find out our x-intercept and our y-intercept. So our x-intercept for our inverse, we just need to make y equal 0. So if y equals 0, I've got 0 is equal to e to the power of x minus 1 over 2, take away 4. Now I could substitute it in like that and then get it by itself, but right here at the very bottom, I've got it already in that form. So if I make y 0 there, I can just simplify it straight away as 2 log base e 0 plus 4 plus 1, and that will get it into the right form of x is equal to 2 log base e, 0 plus 4 is 4, plus 1. Okay, so now all I need to do is find my y-intercept, and with the y-intercept, we know that x needs to be 0. So again, I can just substitute and then simplify it straight away. So e to the power of 0 take away 1 over 2, take away 4. That power just simplifies to -1/2. And I've got my points. Now it will help to, when we're graphing, to know exactly where it goes. So I put it into the calculator to get it as a decimal, but we will be graphing with the exact values. Okay, so if we are looking at the x-intercept first, the x-intercept is approximately 3.77. Put a dot there, but I will label it with the exact value of 2 log base e 4 plus 1 comma 0. And the y-intercept is about -3.3. But I'll again label it as 0 comma e to the power of -1/2, take away 4. And now I can just draw my graph. I was just going up with where the x and y are on purpose. Y equals x, sorry, y equals x, because that will help me with graphing on where they're supposed to cross. Okay, so now I've done that. That links into understanding part II, which is referring to find the values of x correct to 3 decimal places for which the inverse and g of x intercept. So we know the line y equals x. That is the mirror line that we need to understand. So that's where all of our intercepts will be. So that means all I have to do is scrap this, and instead of saying y equals 2 log e, I can just say y is x and go x is equal to 2 log e x plus 4 plus 1. This is one of those questions where you just put it onto your calculator and it'll give you your two values, which will be negative 3.914 and the other one will be 5.503. Moving on to the next part. We've got the diagram below, shows parts of the graph of the function with the rule. F of x is equal to k log base e, x plus a plus c, where k, a, and c are real constants. Before we get started with looking at this next part, the basic graph, I'm just going to draw here. If we are just looking at a basic log graph, we already know that there's an intercept here at 1. That's the key part that will help us here. So it says the graph has a vertical asymptote with equation x equal negative 1. The graph has a y-axis intercept at 1, and the point P on the graph has a coordinate P10, where P is another real constant. So state the value of A. So A is referring to the horizontal shift, and we can see that since there is a asymptote at negative 1, there's been a horizontal shift 1 unit in the negative direction. So shift 1 unit in negative direction of x-axis. So for that to occur, we must have x plus 1. So y is equal to log base e x plus 1. That's the first thing. So that means a must be 1. The second part, that would mean now I've got this at negative 1, an asymptote, and my graph is going through my origin. So when it says I need the graph has a y-axis intercept at 1, it means my graph has been pushed up by 1, which is what the c will do. So c also has to be 1. The second part is show that k is equal to 9 over log base e p plus 1. So we are going to substitute our values that we have for a and for c. Then what we will do is we will look at substituting the value of p and 10 into x and y and solve for k. So we've got f of x is equal to k log base e x plus 1 plus 1. I'll substitute the p and 10 in now. So that will give me 10 is equal to k log base e p plus 1 plus 1. So we'll take 1 to the other side, and that will give me 9 is equal to k log base e p plus 1. We can start to see it already. To get k by itself, I divide everything by the log, and that will give me 9 over log base e p plus 1.